Good morning, everybody. Welcome to our workshop number 21, titled Young Gas Potential in Cretaceous Rocks along the Eastern Cordillera of Colombia. And our speaker today is Dr. Cesar Mora. I would like just maybe to remind you that today we will have our first talk on gas, that as you know is our transition fuel product. And next week, we will have the pleasure to have 1 minute, let me just put the laser. Next week, we will have the pleasure to have Dr. Carlos Maserali, one of the most important professionals that have been in Colombia for several years. And he's going to talk about the exploration trends and opportunities in Colombia. We will have as well the MinCiencias group talking about the advance of the different convocatoria that I will illustrate to you at the end of this talk. We will have on July 22nd, the pleasure to have Dr. Alberto Garcia from the Drummond Company talking about the exploration in natural fracture reservoirs in the Cesar Rancheria Basin. And the last week of July 29th, we will have also a special guest, Dr. Luis Ernesto Ardila, who is going to give us the talk titled Exploration Efforts Today and a Vision for Future Endeavors. So we have a very interesting talks on July, and also next week I promise you will have the list for our talks in August. Don't forget that we have here the map with the areas that the agency has identified of interest to be nominated. You know, anytime in the future, in the coming months, for sure, the round process is going to be open and possible for gas areas. And in this specific map today, we have illustrated areas with mainly gas production and also areas with gas, associated gas. As you know, based on our findings, 89% of our areas with gas are gas associated. So we have the hydrocarbon gas and the hydrocarbon liquid together. Okay, so we have 30 areas that we promote, that we, how do you say, call the attention to all of you as interested areas to be nominated in the future. And don't forget that the agency continue working with the identification of more opportunities for gas in our play fairways areas. Okay, as well, we have here the link where you can address any of those blocks, technical information of those blocks. So that information is in this link in our website. I will request Daniel later to put this address as usual in our chat. Well, we have Dr. Cesar Mora today. Dr. Mora is a geologist with a master's science in petroleum systems and 33 years of experience in petroleum exploration projects. Expertise in petroleum geochemistry, petroleum system modeling, and yet to find assessments. Director, coordinator, and interpreter in projects in companies such as Ecopetrol and Cipetrol. Since 2024, Cesar has worked as a consultant, and since 2014, as manager of Cuenca Asesorías Geológicas, SAS. He has also been professor of petroleum geochemistry and petroleum system modeling at several Colombian universities. So just as a closure, let me just remind you that the workshop next week will be titled Exploration Trends and Opportunities in Colombia by Dr. Maserali. And we will have the Doctora Carolina Munera from the MinCiencias also talking about the Jóvenes Investigadores process, convocatoria, okay, on July 15th. And don't forget as well that on July 29th, that Friday, last Friday of July, we will have what we call the wrap-up of the Pacific efforts done by the ANH. And we will have night talks that day. We will have the ANH, we will have the Geological Survey, the Universidad Nacional, Universidad de Caldas, DIMAR, la Armada Nacional. We will have also the UTCH, which is the Universidad Tecnológica Chocó, and we will have the PGS representatives as well here, And all of them are going to talk to you what is the progress of the finding of gas in the Pacific area of Colombia. That is going to be here in person and also in a virtual way. I mean, so we will send to you the corresponding link for the people interested in our findings and our efforts in the Pacific area. I'm going to switch into Spanish for a minute. I offer my apologies for that, but it's just to illustrate the couple of convocatorias offered by the MinCiencias group for all the geologists, engineers, and people related to the industry. Let me read it for you. Los invitamos a consultar los términos de referencia. Son dos convocatorias en progreso hoy en día con MinCiencias, con la financiación de la Agencia Nacional de Hidrocarburos. La primera es convocatoria fortalecimiento de actores, industria y hidrocarburos. El link está en este es el link. Le voy a pedir a Daniel que también durante la charla de César lo coloque en el chat para la primera convocatoria. De igual manera, les recordamos que se financiarán proyectos de investigación en el área de yacimientos no convencionales hasta un monto máximo de financiación de 876 millones de pesos y para proyectos en temas de exploración en cuencas colombianas, un monto máximo de 1.500 millones de pesos. Por favor, consultar las áreas de investigación de la convocatoria. La convocatoria está abierta hasta el 19 de agosto a las 3 de la tarde y pueden ser remitidas al canal oficial de MinCiencias, cuya dirección está aquí al fondo. Y, listo. Bueno, en este corre-corre me faltó hablar de la otra convocatoria. La otra convocatoria es para jóvenes investigadores que la doctora Múnera nos comentó la semana pasada, también en la misma duración, para que jóvenes de último semestre o recién graduados entren a ser parte de estos grupos de investigación y igualmente Daniel estará suministrándoles a ustedes el respectivo link para que continúen progresando en el entendimiento de estas convocatorias. Okay, now I'm going to switch again into English and invite Dr. Cesar Mora to start our talks on gas in the Eastern Cordillera of Colombia.
Thank you, Miguel. Good morning, everyone. I want to thank to the ANH for this opportunity and obviously to the colleagues that are participating in the talk. Okay, we will be talking about the gas potential in the Cretaceous stratigraphic sequence along the Eastern Cordillera of Colombia. We use the word giant because we really believe that we have a very important prospective area here for gas. And we hope to show the evidence today. I want to mention, it's very important to mention that I'm talking on behalf of a huge group of colleagues, a very huge amount of geologists that have been working with the ANH during last 6 years. Here I have some of the projects that are related with this talk. We have more than this. You can see this is a huge group, and also it's easy to see that this is a multidisciplinary approach for these studies. Why we are talking about gas is simple, because we know that the country needs gas. We know that the world needs gas, and the Eastern Cordillera will be, or the Eastern Cordillera is one of the main geological province with these options, with very good possibilities to get gas resource for the country. Okay, at the first point, we are going to review some points related with the gas that we currently have in Colombia. This is coming from the ANH, from the last project that the ANH made last year with the Universidad Pedagógica y Tecnológica de Colombia. And here we can see some very important points. The first one is that if you see here the 1P reserve, they are small, maybe 3 TCF. 3 TCF is a situation that is, we believe it is risky for the country, especially with the new global situation related with energy supply. We need to change that. The country needs to find additional resource, gas resource. Even we talk about 2P and 3P, we can see that we need to improve all these amounts. We need to improve our studies related with gas. The demand is going up, you know that, and it's probably that if we don't add new reserves, the country will need to import this energy, the gas energy, which won't be good for us, especially because everyone is trying to use, every country that has gas is trying to use it, and it's not easy. It won't be easy for the future to get gas. We know that the better option for the country is to find reserves. We need that. Here we have a brief summary of the production, gas production in Colombia for last year. You can see here that the annual gas production was very close to 700 million cubic feet. Gas production from 2019 to 2020 had a reduction of 10%. It's not good. It wasn't good. 2021 total gas production was 677 million cubic feet and was a reduction around 5.3%. The other important point is that the main production is coming from 3 areas. Cordillera, talking especially about the foothills. Llanos, talking about Cusiana, it's almost the same area. It's foothills and llanos because an special situation there, but it's geological. We are talking about in mainly the same geological habitat. And then we had Lower Magdalena and Guajira, which is our offshore basin with gas production. Then we can see here that we need to improve. We need to include another areas in this map, not just these where are concentrated current production. Okay, now we are going to talk about the intercordillera. First point, talking about the geological framework. We are associated this hydrocarbon potential, this gas potential to the Cretaceous earth rock. Then if we see the geological map, immediately we can think that we have good news. We have a lot of green here, a lot really. and everyone knows that we have very good source rock there. That's the main point. We don't need too much study to see that. The second point is that in general, during last 30 years, everyone that was working in Eastern Cordillera or that were thinking to work in Eastern Cordillera was thinking in gas. For the oil industry in Colombia, the Cordillera Basin was always a gas-prone geological province, which is very close to the data show that it is that's the fact. But we have now a strong database. We have a huge amount of information and interpretation that could allow to jump in this basin. We need that. We need to jump to a higher level of exploration activities in the Cordillera, sinking in the gas prospectivity. The first step for our analysis was to divide the basin in different geological provinces. Yeah, it was necessary because this is a very complex basin, and we know that we don't have the same prospectivity in everywhere. Then we are going to describe a little bit about these areas. First, we have non-prospective areas. These areas correspond to the Los Cobardes anticline. In the northern part of the basin, we have this area, which is a complex with meta-sedimentary rocks, also here in the very close to the axial zone, we have Arcabuco and Floresta. We have the Floresta Massif. We have Jurassic and we have metamorphic rocks. And also we have this huge area in the southern part that correspond to the Ketame Massif. We classify this as a non-prospective areas for gas, for petroleum systems related with the gas. And then we have geological province where we have the option to find gas. And then we have for the western part of the basin, we have the Tablazo subbasin. We are calling Tablazo because this was a way used 30, 40 years ago for this part of the basin. Everyone knows where is the Tablazo subbasin. Then we are using again that name. Then we have the axial zone of the Eastern Cordillera. And here we are including different tectonic settings. We have the southern part of the axial zone, which is where the Cretaceous source rock are very deep. Then we have the central part where the Cretaceous is shallow and where we have oil production. And then we have the northern part where the tectonic style is complex. Then we can divide a little bit more this, obviously. But for now, we are using this area as a geological province with very specific opportunities. And then we have the Cocuy Medina subbasin. It's a huge area again where we have the Cretaceous source rock in the surface. And the main difference probably from Tablazo and Cocuy Medina subbasin is the level of tectonic inversion is highest here. In general, these Cretaceous correspond to lower Cretaceous, more lower than upper. And here in the Tablazo subbasin, we have both. We have a lower and an upper Cretaceous age. And From the Bogota area to the south, we call this area Fusagasugá, Colombia. We are talking about the name of two of the main synclines in this area, the Fusagas synclines and the Colombia syncline in the southern part. As I hope to show you, we have different opportunities in every one of these areas. Okay, now we can talk about the stratigraphy framework. The main point here, we are using this chronostratigraphic charts from Luis Vergara from our ANH project, but Luis Vergara was the director of this stratigraphy group. And again, we have here, just looking the chronostratigraphic chart, good news. We see that we have a lot of intervals with shales, with limestones, and with identified soft rock intervals. In the upper Cretaceous, late Cretaceous, and also in early Cretaceous. And when we go to the west or to the east, we know this is present. And then according to the presence of the Cretaceous sequence, we are in a very, very special place in Colombia. We have the Cretaceous phases, we have the soft rock phases, and we have a very regional distribution of that phases. In terms of the structural model, this is coming from the same project, and the director of this activity was Andres Mesa. And here we have different tectonic styles, and according to that, we have different opportunities for gas and oil, or for oil and gas. In the southern part, we have here the syncline, the Carmen de Apicalá syncline, when we have the Guando field, where we have oil and gas, and where we can see that especially the lower Cretaceous is in the subsurface. We have that units there. We have lower Cretaceous preserved in the deepest part of these inclines. The upper Cretaceous is different. We have the upper Cretaceous, La Luna formation or Loma Gorda formation is in a very good location in the Carmen de Apicalá incline, but in these inclines we have these units very close to the surface. We have to analyze that in order to define at the end the prospectivity. In the axial zone, in the southern part of the axial zone, we have the deepest part of the basin, probably where the Cretaceous is involved, but we know that in some part of this sequence will be very difficult to get the lower Cretaceous. Probably in this area will be the best option, will be in the upper Cretaceous. And we know that we had gas there. Remember that in Suezca 1, Texaco found gas in very close to the base of the Chipaque formation. Then we know that it is a play, a proven play for that part of the basin. Also, we have to the east, we have these inclines for the Medina area, where we can also have opportunities for gas, oil and gas. In the central part of the axial zone, we have the Corrales and Bolivar area. We have the Suapaga fault, which is a very, very important tectonic system here. And we have oil accumulation and gas associated with that oil in the fields Bolivar and Corrales. We have the Cretaceous, the complete sequence here in this area. We have upper Cretaceous in a very good position, and also we have lower Cretaceous. And in the northern part, we have a complex, very tectonic complex configuration here in the Gibraltar area. And you know that there we have gas, we have condensate, we had fluids from a very high maturity level of oil window, oil fluids that correlate with the end of the oil window at the beginning of the gas window. You can see that we have different tectonic styles, but in every one, we have opportunities to include those Cretaceous sections with opportunities for gas. In terms of the hydrocarbon occurrence, okay, what we have in the basin, we have the Gibraltar field, Corrales and Bolivar, and we have Guando. As we are going to see, here we have oil and associated gas. Also, we have a lot of oil seeps, and also another point is that here in the boundary of the basin, we have the foothills fields that we will be talking a little bit about that area. Then we can see that the petroleum system is proven here. We have production, we have oil, we have gas associated. And also we know that we had opportunity for another kind of gas in the basin. This is a summary of the gas occurrence in these fields, including the foothills area. The first map is related with the certified gas. We have 18 producing fields, and the highest production for the country is coming from this area. You can see here, 71% of the gas production is coming from the foothills. That's huge. We really need to find another areas like this for the future. The other point is that according to the gas composition, all these gas is associated. It's gas associated, and also is wet gas. We have the option for natural gas and also for LPG. Wet gas is the main. All this accumulation corresponds to wet gas. We don't have an accumulation of dry gas or just natural gas with methane. This is a very important point because that means that thinking in the proven place, thinking in the reserves we have, we know that all are related with a very specific thermal maturity level for the source rock. They are related with the end of oil window at the beginning of the gas window. But that's not the only option we have for the basin. You know that we have a very high maturity level for that source rock intervals in many places along the basin. Then we are going to see a little bit about that. Okay, how we can connect the geological framework, the petroleum system elements and processes, and the gas production in this area. Here we have a summary of chronostratigraphic chart for the Cordillera, Cordillera Basin, and also we have the foothills area. We have here a summary of the petroleum system elements and processes. You can see that we have at least different reservoir units, different seals. We have a very good overburden sections, and we have trap formation in a different geological times, and we have generation processes, generation, expulsion, and migration processes that are concentrated in the Miocene, maybe late Oligocene to early or late Miocene. And also we have at least 2 critical moments. That means probably we have the option to get mixture fluids, some coming from the first hydrocarbon expulsion and migration processes, and the second one coming from the last one. And probably most of these gas are related with this, with the last one. The other important point that we can see here is that the production is concentrated in reservoirs from the late Cretaceous. You can see here in Cupiagua, Cusiana, Floreña, Guando, Corrales, Bolívar, El Niño. All this gas is coming from the late Cretaceous reservoirs. And also we can see that we have a low production, but not also in this reservoir interval, we have very high production, very, very high production, more than 1,000 million cubic feet. And the next reservoirs correspond to the Paleogene sequence, and we have reservoirs in the Paleocene units, Barco Formation especially, with very high production. And also we have this production coming from the Eocene reservoirs. We have production from Mirador area, and we have different fields, or so many fields that are producing for more than once reservoir. This is good. This is a very good picture, because now we know from the proven place that we have the option for different, for stacking reservoirs. We have the option for different kind of production going to the very high in the foothills area. We had at least 3 reservoir intervals. We had at least 2 soft rock intervals. We had at least 2 critical moments, which is good. That's really good. It is a little bit complex, but it is good thinking in the option for that play, for gas plays in Eastern Cordillera. Okay, now we are going to talk about the petroleum system model a little bit. It's just a brief summary about source rock and gas geochemistry and some modeling like this kinetic modeling. As I mentioned, we have at least 2 source rock intervals, one related with the lower Cretaceous, Aptian Albian sequence, more or less, yeah, and the other one to the upper Cretaceous, maybe late Cenomanian to Santonian. We have their different lithostratigraphic units. We have units like Paja Formation, Tibasosa Formation, Fomeque Formation, Chipaque Formation, Frontera, and Loma Gorda formations. These soft rock intervals are, in most of the cases, are in a very high maturity level. That means the geochemical characterization that we have didn't correspond with the original hydrocarbon potential. Then we use basin modeling. We use kinetic models to calculate the original hydrocarbon potential. And here we can compare the results for Fomeque Formation and Chipaque Formation. This could be an average for these units, for these lithostratigraphic or chronostratigraphic intervals. And we have very important things. The first one is that the Fomeque, or their equivalent, stratigraphic equivalent units, has a very high hydrocarbon potential, initial hydrocarbon potential, very high TOC, average of 5%. Average means we have in so many outcrops, especially this information is coming from the Nexen projects 15 years ago. We know that could be very close to 10%. Also, we have very high hydrogen index. We have a very good quality of the kerogen, mainly type 2 oil prone. And even in the Chipaque and Frontera formation, where the initial hydrocarbon potential is a little bit less, these values are very similar to the values that we can get from La Luna formation in middle Magdalena Basin. The other point is that you can see that we have a lot of gas here for this kind of soft rock or organic phases. And that is an important point from the petroleum system point of view. We know that most of the conventional gas will be related with oil, will be related with the oil window, will be related with the oil-prone soft rock. We have the opportunity for gas related with the highest maturity level. But here, just thinking in the conventional place, we have a very good opportunity for gas sinking in the original hydrocarbon potential of these soft rock intervals. In terms of the petroleum system modeling, I'm going to show just this example. This is located, this is a well. Some part is a well, but for the lower Cretaceous is a pseudo well located in the Corrales area in the footwall of the Suapaga fault. And according to these results, according to the burial history of the thermal model we use, the lower Cretaceous is into the gas window, maturity level close to maybe 1.4. And La Frontera formation is at the end of the oil window. And this match with the oil and the gas we have here in these accumulations. Probably the central part of the axial zone will be one of the best options if we want to combine oil and gas. Is the main area where we have one of the main areas when we have options for oil. And it is related with different elements, but probably the most important is the maturity level of the Cretaceous, the upper Cretaceous soft rocks. As a consequence of this history, we have in this part of the basin, and in general and in different parts of the entire basin, we have at least two critical moments. This is the rate of hydrocarbon expulsion. That means this is an expulsion event, hydrocarbon expulsion event. This one related with the Tibasosa formation in this case. It is concentrated here into the Oligocene, early Oligocene. And if we go to the highest maturity areas in the basin, probably we can get that, we can go with that event to the Paleocene, very, very early hydrocarbon generation processes. And then we have, during Miocene, we have an expulsion coming from the lower Cretaceous soft rock, and we have the main hydrocarbon expulsion from the upper Cretaceous. This is very similar that the results we are getting in another basins in Colombia. It's really the best way to explain what we have in our basin and why it's easy. Because if we have mainly two soft rock intervals, one in the Aptian Albian and the other one in the Turonian and Santonian, but it's obviously the easy way for petroleum system modeling will be to get two hydrocarbon migration pools. And we can see that in the geochemical information from the proven areas. About the gas geochemistry, this is very new information that is related with the last two projects from the ANH. And we have information here from the foothills, from the axial zone, from Corrales. Here we have the wells, Pauto, Cupiagua, Cusiana, Floreña, Guando, Corrales, and Bolivar. What we have here, the main point is that we have wet gas. The gas is not 100% methane, we have a very wet composition. 82% of the analyzed wells in this area have more than 5% of LPG. And that's the reason the main production from LPG in Colombia is still coming from the foothills, because we have that composition. And the LPG probability, the P15 is around 8.8. That percentage is very high in compared with all the data we have for the country. It's good enough to have production. It's good enough to have LPG from that processes. If we separate that in the associated gas. The other point is that all these correspond to thermogenic gases according to the composition, to the general composition and the isotopic composition of the methane. And also the other point is that gas is related with primary cracking. That means we don't have here in the proven place a secondary cracking. All the gas is related with the oil, with the oil window, and because of the composition must be at the end of the oil window or at the beginning of the gas window. Okay, now we are going to talk about source rock reservoirs, natural fracture reservoirs, and we have to start with the Nexen projects. Nexen was working, probably was the first company that were working with source rock reservoirs, and that projects were concentrated in Eastern Cordillera between maybe 28, I'm not sure, 15 years ago, something like that. And we are going to see some information about these wells, Carupa 1 and Sueva 1. Carupa 1 is located in the Rio Frios incline or Chiquinquirás incline. You can see here the sequence that was drilled by the well, including Guadalupe, Conejo, Chiquinquirá, Simiti formation. And in the eastern part of the Bogotá, they drill Sueva 1, they drill Junín 1, and the target was to see Chipaque formation and Fomeque formation. And Nexen got a very good, very important information from these wells. I'm going to show some results. First one, from the Carupa 1, they found a sweet spot. They found an spatial more than very close to, we have the thickness here, 270 feet. Shales with a very high maturity content, with a predominance of kerogen type 2, maturity level very close to 2%. And we have in general, they was possible for them to define a sweet spot, a very good sweet spot, and they have chose. They had chose from these wells. And in the other, in the eastern part of the basin, from Sueva 1, also this I forgot. Maybe I forgot. This is coming. This information is coming from Chipaque or Frontera. Really, they were working here with Frontera formation, and the chronostratigraphic equivalent of La Luna formation. And for the lower Cretaceous in the Sueva area, they found another sweet spot, a very huge. You can see here the thickness is very high. And the TOC and the hydrogen index are really high. When we apply methodologies to calculate the original hydrocarbon potential is very, very high, probably one of the highest hydrocarbon potentials in our country. Also, we have kerogen type 2, we know that because they did a lot of organic petrography. Maturity level is higher than, obviously is higher than the maturity level from Chipaque and Frontera Formation. And that's one of the points we have to keep in mind in order to define regionally the best areas with chance for gas production from these natural fractured reservoirs. How we can calculate or to estimate the volumes of the potential, the gas in place for this kind of place. We apply a methodology coming from petroleum system modeling. This is an example of the how can we apply this methodology. In this case, this is Carupa Formation. We can see here the burial history. We can see we have a mistake here about the lithostratigraphy, but we can see the maturity level of the units. And this is the general proposal for kinetic models. That this is coming from all the information that basin modeling approach are getting during last 10 years in the United States. We know that the kerogen has a primary cracking for oil and a combination between primary and secondary cracking for gas. That's the reason while the oil is going down in a source rock reservoir, the gas is going up into the gas window. Why? Because most of the oil is coming from cracking of the oil. That's the reason, even for high maturity levels, we have a very good opportunity to get oil, to get gas in this kind of place. And we can estimate using this modeling the amount of total gas retained in the source rock interval, and retained is this, and the free retained gas, which correspond to the gas in place. Then we have an easy way, really it's an easy way to establish, to define how much gas and how much oil, obviously, but how much gas we have in a place like this. We can compare these results very quickly. For example, here, for this maturity level, 1.8, in a unit, in a source rock interval, when we have that maturity level, the oil is almost close to 0, to 1. In this case, is very close to 1 million barrels of oil equivalent for a square kilometer. We don't have oil, very small options, because of the maturity level, because of the secondary cracking. But for the gas, at the same maturity level, you can see the amount of free gas we can have, very close to maybe 25 BCF per square kilometers. That's a very huge value, very, very huge value. That's one of the reasons, probably one is the main reasons we believe that the gas potential for this kind of place in the Eastern Cordillera is really high, because we have a very good hydrocarbon initial potential, and also we have in some areas, very huge areas in the basin, that units in this kind of maturity level where we can get a lot of retained free gas. Remember that we really need free gas, because the difference between these two correspond to the absorbed gas, which is not possible to produce in general. Okay, finally, we are going to talk a little bit about jet to find, conventional and source rock intervals. This is coming from the last project from the ANH and the Universidad Pedagógica y Tecnológica de Colombia. Here we can see a summary of the gas discovery. This is the gas in place, onshore gas in place. It's almost 20, 1951. It's almost 20. And if you add the 6 TCF from the Chuchupa and Ballena, that's the amount of gas we have in Colombia. We prove in Colombia 25 TCF. And doing this exercise for trying to define yet to find, we found this value. 28 is the prospective resource of gas for the country, and for the Cordillera, the value is close to 6 TCF. 6 TCF for conventional is almost the same amount of gas we have in Chuchupa and Ballena. That means we have an opportunity here. We have an opportunity to get more gas related with this gas window, with this place related with gas associated mainly. That's the first point. For that approach, we have a detail about how we calculate that gas. Probably it was the first time that calculation was made in Colombia. We were checking everything, and it wasn't part of the previous work, and we now have a methodology that we know we have to improve, and we have to add additional information. And finally, from the jet to fan related with soft rock reservoir, this job was made by the ANH 2 years ago. And then we have here the result for insert Cordillera. Here we have prospective resource, and here we have recoverable prospective resource in TCF. Okay, let's check this value, almost 800 TCF. It's huge. And these are related just with this area. The Apicalas incline, this is the Cocuy subbasin, and this is the northern part of the Tablazo subbasin. We define that areas, or we exclude another areas for different reasons, because we didn't have there the condition. For example, the place so deep, or the structural is very complex. That kind of reasons we use in order to define just these areas. And using a recovery factor of 15%, we have this value, 117 TCF. The value is huge. Remember that we have 25 as original gas in place, proven in Colombia. We are talking about reserves 1P, around 2.9 TCF. And here, related with this soft rock reservoirs, we are talking about something bigger than 100 TCF. Obviously, this is the starting point. We need additional information. We need that some companies get the gas. We need the new data, geological, geochemical. We need a lot of information in order to have a better understanding of this situation. But anyway, as I mentioned at the beginning, we know that in this geological province, in the insert Cordillera Basin, we have a very good conditions in terms of the soft rock intervals, Cretaceous soft rock intervals, with a very, very high hydrocarbon potential, initial hydrocarbon potential, with a very good maturity level on that soft rock intervals, maturity level that could be related with wet gas, associated wet gas, but probably the highest option, the highest potential will be related with dry gas, secondary cracking, coming from secondary cracking of the oil on that soft rock intervals, and that will be related with soft rocks reservoirs. Okay, that's all we have. Thanks a lot to attend the talk. I don't know if we have time for some questions, maybe. No, I don't know.
Yes, Cesar, we have time for a couple of questions. So, thank you for the presentation by part from the ANH. And there is a question by Elbert Ordóñez. Could you please provide the reference of the structural profiles or sections that you presented in the slides of the structural geology framework? And there's a second question by Carlos Molinares. Thanks, Cesar, for the presentation and the team for an insightful work. Did you see a timing risk for central north part of the Eastern Cordillera where you made the 1D modeling? When do you think occurs a critical moment? Those are the only couple of questions that we got so far.
Ok, Elber, en la primera página donde están, en la primera diapositiva donde están los trabajos, ahí hay uno que está definido como corredores de prospectividad, UPTC-ANH 2020, y estas secciones estructurales están allí, son de autoría del grupo de intérpretes que estaban dirigidos por Andrés Mesa. Entonces allí lo puedes encontrar en ese reporte. Y la pregunta de Carlos, la forma sencilla, Carlos, nosotros tenemos crudo probado en reservorios hasta el Paleoceno, Eoceno temprano tal vez. Y tenemos mezclas, entonces la carga debió ocurrir en un par de momentos críticos, uno probablemente en el Mioceno temprano y otro más relacionado con el Mioceno tardío. Y cuando uno construye los modelos, es el resultado más simple que consigue y es un resultado que permite explicar lo que nos muestran los fluidos. El gas asociado, probablemente el crudo del primer pulso tiene importante biodegradación. El del segundo pulso hace un refreshing y contiene el gas asociado que tenemos en esos campos.
Okay, Cesar, there's another question by Jorge Toro. He says, I really appreciate you and your colleagues' job. Question, why not considering Upper Paleocene as an additional critical moment for the petroleum system?
Why not Upper Paleocene? Really, there is a critical moment there, Jorge. Yes, you are right. We can include it, and we have to include it. What's the main problem with that critical moment? At that time, probably we have a lot of we lose a lot of migrated oil because of a timing problem in terms of obviously the relation between that critical moment and the tectonic the trap formations. That's the reason we didn't include, but we have an evidence in some part of the areas of the basins. We got hydrocarbon expulsion processes during the Upper Paleocene. You are right.
Okay, Cesar, thank you very much. Thank you for the presentation. Thank you for the questions. It's an excellent presentation and excellent insights for the potential or a giant potential of gas into Cretaceous for the Eastern Cordillera. So now I would like to remind to all of the people that's in here that next week we will have exploration trends and opportunities in Colombia by Dr. Carlos Macelari. We will have as well Convocatoria en Ciencias, Financiación Jóvenes Investigadores por Carolina Munera. To remind all of you that we'll have our workshop of Pacific into July 29th with different presentations that these different institutes and universities that have been working with the ANH in order to show or to understand the high potential that the Pacific could have into this gas transition that we'll have. Now, as Miguel did at the beginning of the talk, I'm going to switch to Spanish to make the convocatoria of MinCiencias quite clear. Entonces, los invitamos a todos a consultar los términos de referencia de la convocatoria Fortalecimiento Actores Industria y Hidrocarburos en el link que ya se encuentra en el chat de esta presentación. De igual manera, les recordamos que se financiarán proyectos de investigación en el área de yacimientos no convencionales hasta por un monto máximo de financiación de 866.135.636 pesos. Y para mayores proyectos en temas de exploración en cuencas colombianas, un monto máximo de 1.500 millones de pesos. Consultar las áreas de investigación de la convocatoria. Como se les ha comentado en las charlas anteriores, la convocatoria estará abierta hasta el 19 de agosto a las 3 p.m. y todas las inquietudes pueden ser remitidas directamente al canal oficial de MinCiencias. Atención al ciudadano, @minciencias.gov.com. Y una cuestión que olvidamos de pronto mencionar al principio de esta charla es que la financiación para jóvenes investigadores e innovadores está dirigida a actores del Sistema Nacional de CTI o entidades del Estado o instituciones de educación superior que cuenten con grupos de investigación, desarrollo tecnológico o innovación con reconocimiento vigente del Ministerio a la fecha de cierre de la presente convocatoria. Interesados en vincular semilleros de investigación, jóvenes investigadores e innovadores de pregrado y recién graduados con formaciones en geología, geociencias, ingeniería geológica, ingeniería de petróleos o programas afines a ciencias de la tierra o cuyas disciplinas tengan relación directa con estas. Recordar que tenemos 3 mecanismos. El primer mecanismo es financiación de beca pasantía en investigación de jóvenes investigadores e innovadores de pregrado y profesionales recién graduados. El segundo mecanismo, financiación de trabajo de grado de estudiantes de pregrado. Y el tercer mecanismo, creación o fortalecimiento de semilleros de estudiantes de pregrado. Para mayor información pueden entrar al link de MinCiencias, minciencias.gov.co/convocatorias/innovación y productividad, convocatoria fortalecimiento, actores industria. Damos gracias a todos los que participaron en esta charla de hoy. Nuevamente desde la ANH, darle gracias a César Mora por la charla. Y nos vemos todos dentro de 8 días con la presentación del doctor Carlos Maserali y con la presentación de Carolina Munera. Muchas gracias.